Hello. Now we will study the modes of heat transfer. So, when the heat is traveling, it is traveling from one location to the location, so sender to receiver. It will be moving. When the heat is going from sender to receiver, this process of transfer will involve three types of process, three modes it will involve. The first mode is heat will get transferred through conduction. It's a different process, different set of rules governs the conduction process. Second mode of transfer is convection. And the third mode of transfer is radiation. So in general, there are these three modes which involve the transfer of heat. In real case scenario, when the heat is being transferred from one location to the location, all three processes are involved. But some specific cases, sometime one or other take the priority depending upon the predominance. But if the medium is not there, if it is a vacuum, in that case conduction and convection cannot happen, because for conduction and convection to happen, there is a prerequisite, and that prerequisite is the medium. We always need a medium if we want conduction and convection to happen. For radiation, there is no requirement, there is no such requirement for the medium. This radiation can happen with or without the medium. It can happen with or without the medium. Okay, so let's discuss all three processes. What's the difference between these three processes? So let's assume this is a sender and there is a receiver. And in between the sender and receiver, I'm putting them in box so we can differentiate among them. And in between the sender and receiver, there are multiple particles. There are the particles of the medium, or you can say atoms are there. These are multiple particles. Okay. So, in case of conduction, what happens? The sender don't directly send the heat to the receiver. What the sender do? This pass on the heat to the nearest particle. Let's call it 1, 2, 3, 4, 5, 6, 7, 8 particles are there. So the sender will be giving the heat to the nearest particle, and the amount of heat it is giving is Q1. The moment this one will take the heat, it will start vibrating because the heat corresponds to energy. The moment particle 1 will be having the energy, it will convert that energy in its kinetic energy and it will start vibrating fast. When it will be vibrating fast, it will start influencing the second particle. And through this influence, it will transfer a part of Q1 to Q2. Not the complete, but part of that. So some Q2 will go to the second particle. And obviously, this Q1 will be more than Q2. The moment the particle 2 will have some energy, it will vibrate, its vibration will increase and will start affecting the third particle. So Q3 will get transferred 3. And this process will go on. So basically what is happening, the particles, they remain at their main location. They remain at their mean location, but their vibration increases. And in this process, they are transferring this heat which they received from the sender and to the nearest particle. And in the end, this energy will reach to the receiver. So there is a thing. Energy is being transferred with the use of medium's particle. Particles are not moving. Only the energy is moving from one to other. Only the energy is moving from particle 1 to the receiver, but the particles remain at their mean location. So this process where the particle only vibrate, they don't move from their mean location, but the energy moves along them. This process is known as conduction. Okay. So for that, as you can see, if the particles are not there, this process will not be happening because the energy, ultimately it has to go to the particle, and through the particle it has to go to the other particle, and then it has to reach the receiver. If there are no particles in the medium, this process will not be possible there. Okay. So that's your conduction. In detail, we will separately study that process. Now let's go to the second process, that is convection. One more sender I am taking, and there is one more receiver. There is our receiver. And in between the sender and receiver, we are having multiple particles. 1, 2, 3, 4, 5, 6. So in this process also, the sender gives the energy to the nearest particle. So sender is providing energy Q1 to the nearest particle. This particle will have this energy, and the moment this particle will have its energy, it will vibrate if it is a solid. But this particle might be loosely connected to its mean location. So if that's the case, this particle, this particle will do, along with this energy, the moment this energy is being transferred to this particle itself will move to the end location. So after carrying this heat, after carrying this energy, this particle will move to its destination. The destination is the receiver, because there is a deficit of energy there at the receiver. Okay, so this position will fall vacant. If this position will fall vacant, what will happen? This particle will move to this location. So when this particle is moving to this location, what will happen to this particle? Because there is a vacancy created here. This will move here. And this particle will move here, and this particle will move here, and this particle will move here, and this particle already moved to its location. So this is like a line. So people gets the packet, they move at the back line, and line moves forward. One more time, the sender will give heat or energy to the new particle which has come to this location. The heat will be provided to the new particle, which is this particle. Okay. And after carrying this heat, the second particle will also move here. So when the second particle will move, the particle which came there at this location, it will locate, and this particle will locate, and this particle will relocate, and this particle will also relocate. So this process will go on. So in this process, what is happening? Along with the transfer of heat, the particles of the mediums are also moving. So as you can see, if the particles are connected loosely with their mean position, they tend to have more of convection. But if the particles are tightly connected with their mean location, like in case of solid, they'll tend to have more of conduction. So it's all about that. Even in case of conduction, convection is already happening. Meaning if you talk about the metals, inside the metals, atoms will follow conduction process, but inside the conductor there are electrons also. So electron will follow the convection process. So when we have that metallic rod or metallic body, in that case conduction as well as convection will be happening there. Okay. Now let's talk about the third process. In case of third process, I am making one more diagram. There is your sender and there is a receiver. And in between we are having the particles. Just like the previous cases, we are having the particles. So in this case, sender will be sending the heat, but the sender will not be giving the heat to the nearest particle. What this sender will do, it will directly throw the energy to the receiver without the use of medium's particle. This process is known as radiation. In case of radiation, the sender throws the packet of energy directly to the receiver and continuously throws that heat. So in first case, which is the conduction, heat is given to the particles, nearest particle, and these particles transfer this heat to their nearest particle, and through that process the heat gets traveled till the receiver. Second process, heat gets transferred to the nearest particle, and the particles carry this heat along with themselves, and they take this heat to the receiver. And the third process, sender don't give this heat to the nearest particle. It does not give this heat to the medium's particle. It is directly sending this heat to the receiver. So these three processes represent conduction, and this one represent convection, and this one represent radiation. Whatever material, whatever matter you are talking about, all matters perform all three processes. In case of solid, the conduction happens predominantly. In case of liquid and gases, it's the convection which happens predominantly. And in case of vacuum, if the medium, there is no medium, in that case obviously there is only radiation which will be happening. Otherwise, radiation keeps happening in case of solids as well as in case of liquids. Okay, so thank you.